Either that x plus 2 has to equal 6 because the absolute value of 6 equals 6, or it can equal negative 6 because the absolute value of negative 6 is also 6. So we split this into two separate equations where we get rid of the absolute value bar, going, well, either x plus 2 equals a negative 6, or x plus 2 equals 6. In which case, either x equals, if I subtract 2 on both sides, x equals a negative 8, or x is going to equal 4. Those are our two possibilities. All right, our next one is the one we have to be careful on. I don't have the absolute values by themselves yet, so you have to do that before you can split it. And so I divide both sides by negative 3. If I had an inequality, I'd switch the sign. But we are going to have absolute value of 3x plus 2 is equal to a negative 3. And this is the difference between 2 points on that last test or not. You can't solve this. This is no solutions. What can I put in here where I take the absolute value of and it comes out as a negative number? You can't, absolute value automatically means it's 0 or it's positive. The lowest value an absolute value can be is 0, which is far and away from that negative 3. So that is no solutions. Absolute values can never equal a negative number. 0 is the lowest it can go. Questions on either one of those two? Don't miss this. We're talking about absolute values again, and this is going to be another one that's on the test, where it's going to be, I'll have one probably that's unsolvable. If you solve it, you get -2 right off the top. If you solve it, if you go even worse than solving it in some kind of fashion, you can lose even more points, versus the person that just puts a circle with a line through it and they get full credit. So make sure you're careful with those. All right, what questions do we have on the homework? The graph questions? Okay. So that would be like 21, 23-ish. So what they're asking in 21 is they're saying, when is that equation less than y, or less than 0? So you're going to say, okay, y is taking the place of that 0. So I'm asking, when is this value less than where y equals 0? Well, y equals 0 at this line. So anything below that line that's on the graph will work. So then we just look at the x values that correspond to anything that goes to the y. Well, that must mean that x must be less than negative 3.5, because at negative 4, it'd be down here. Negative 5, it'd be down here. 6, it would be down here. Same thing over here. Yeah?
Just a question. Why is it not less than or equal to?
This one is less than. This one's less than or equal to.
Just
Yeah, that's how I phrased the question. That's why it can't be less than or equal to. And it starts with here. So our next one is greater than or equal to. So I'm just asking, when is this graph above y equals 0? And y equals 0, once again, is the x-axis. That's where y equals 0. And I circled the whole part that is above it. And I'm just asking what x values correspond with these values. Well, that would be anything that's less than or equal to this 1.4. Because 1.3 would be to the left of that. 1.2, 0, -1, -3, so on and so forth. Real quick, we'll do the other two, because these are good ones to put on a test. Because they should go really, really quick. Or if you don't understand what's happening, they take really long. So these are a little bit more elaborate because I didn't actually take the picture. That's why. All right. Let's use this photo now. All right, so this one says 2x minus 3 is greater than 5. So this time we're looking at where y equals 5, and I was nice enough to even graph that for you. I even put y equals 5 on here. And since I'm looking for where it's greater than that, I'm just going to circle the part that's above the line and just list all the x values that correspond with that line, which should be any place where x is bigger than 4, because if x equals 5, that's up there. 6 would be in that circled area as well. Same thing with the last one. I'm just saying, when is this equation less than this equation? So we look at our two equations. I have my negative 3x minus 7. I graph the x plus 1 for you, and I just asked, when is this x plus 1 less than this one? So I just got to look when it underneath that red line and what x values correspond to that. Yeah?
For 25, how do we know that x is greater than 4?
Because of what I said, I guess. Remember, I'm saying, when is it greater than 5? So in other words, when is this equation bigger than where y equals 5? So I plotted y equals 5 for you, and you just had a circle, where is it bigger than that? And that is anything on this line. This is definitely bigger than that line. All right? And so what you're going to do is you're basically drawing a wall. And you're saying x values to the right of that wall work, because that would be part of my circle part. Anything left will not work. All right, so that wall is at 4. And since it's just a greater than, we're not going to have an equal sign, so we'll just have x is greater than 4. So your goal is just basically a circle. Is it above or below that target? And then give me the x values that correspond with that. All right, other questions? Other questions going once? Yeah, Gabby.
Why is 35 no solution?
So 35 is asking where 35, let's take a picture. Upside down U means intersection, so where do they overlap? If I drew a graph of both of these, let me just get rid of that. If I drew a graph of both of these, maybe I should make it all, whatever. It's just not going to be nice. If I did the graph of negative infinity to negative 5, it would look something like this. So we have negative infinity all the way to negative 5, so it'd be kind of there.
Oh, so it's okay.
Yep, and I think the hard part is that negative 2, because it kind of looks like there would be an overlap, but if I plotted this exactly on top of the same thing, this would be my negative 2, and they don't overlap.
Okay.
So if you're doing your graphs, make sure they kind of match up, and you don't look at 2 to 3 being overlapping, because they really don't. Because it'd be easy to say, 2, 3, and 4 overlap, but they don't. That's probably a good one to graph, because I could just see in my head making that mistake too. Other questions? Go once. Twice. All right, if there's no other questions, then we are going to go on to today's lesson, which are absolute value inequalities. Now, the key to solving an absolute value inequality is to ask yourself, does it say less than, or is it a greater than? Don't worry about the equal to, we just throw that underneath. So as soon as you see absolute value, you're going to look at your sign, and you're going to say, is it less than, or is it greater than? Because knowing that tells you what to do next. And we'll kind of do some graphs down here to see why it is the way it is. But first, we're just going to explain what we do. So if it's less than, it is going to be an and statement. And in fact, we're going to set up one inequality. So as soon as you see 1 minus 2x absolute value is less than, you're going to drag that 9, and you're going to make it negative, and you're going to throw it in front. You're going to make it positive, and throw it right there. And then what you're going to do is you're going to keep this and throw it in those two places. So we keep it going the same direction. So we rewrite that as negative 9 is less than 1 minus 2x is less than 9. So a less than statement turns into a compound statement that has less than symbols in both places. And then you just solve it. You just solve it to get x alone in the middle. Do not forget that when you divide by negative, because that's what's happening here, we switch our signs. And that absolute value would just be 4 is greater than x is greater than negative 4. If you see a greater than symbol, so this is the exact same thing, except this time I have a greater than statement. We're going to write two equations connected with an or statement. We are going to connect them with an or statement. Now with this, you are going to rewrite one that looks almost identical to it, except minus the absolute value bars. So if we notice our absolute value symbols just disappear, and we still have a greater than. Well, we still have to deal with that -9 issue. So we're going to write the other one almost identical, except we're going to flip whatever symbol was given us, and we're going to make a -9 on the end. All right, so we're dealing with both the positive and the negative, but when I focus on the negative, we're going to flip that sign. So once again, a less than, we write one statement. Greater than, we write two statements separated by an or, and we'll talk about why we do that on the next two problems, because it breaks it down into just absolute value of x is less than 3. Well, let's go ahead and go into that. So the first one says the absolute value of x must be less than 3. So let's just think about values that work for this. 3 almost works for it. We're just a little bit off. So 2.9 works, right? Absolute value of 2.9 works. 2.8 works. Let's go quicker. 2 works. 1 works. 0 works. 0 is less than 3. Does -1 work?
Yes.
Does -2 work?
Yes.
Does -2.9 work?
Yes.
-3 is pretty much the last one that's going to almost work, right? Because -3 doesn't quite work, because -3 would be not less than 3. So -4 doesn't work. So we're looking for that small window. We're looking for that small window between 3 and -3. And if you can kind of picture that, that is an and statement. I'm putting x between two values. In fact, we know the two values, 3 and -3. This is why when we have a less than statement, you are going to, let's go ahead and mark that. So this is a less than statement. It's less than, so we're going to write one equation. And that really is an and statement. And that one equation is just going to be, we're going to, instead of +3, we're going to start with -3. Is less than x is less than 3. And if we do a graph of that, because we were supposed to do a graph and we're supposed to write our solution in so let's do our graph first. I'm not looking for anything spectacular. I'm just looking for a -3, maybe a 0, and a +3. And since there's no equal to signs, we know x has to be bigger than 3, so we're going to open in the positive direction. We know it has to be less than a +3, so we'll open in the negative direction, and we'll go ahead and scribble that in. So those are all our solutions, because we said that makes sense, because 4 wouldn't work and -4 wouldn't work. Yeah, one.
Didn't you say that -3 would not work?
-3 will not work.
Oh, that's right.
That's why I used the parenthesis. Yep. Anything, one bigger or one smaller, however we're looking at it, will work, but we have to put a parenthesis on it because -3 is the last value that doesn't work, I guess. All right, then our notation of this would just be -3 to 3. I think I asked for both of them. I can't see the total thing. I just see write the solution, but I'm pretty sure I asked for your graph. All right, this is why we write one equation. So if it's less than, we're looking for something that's between two values that work. And you can always boil back down to this example if you're on a test and you forget. Just go back down to and write absolute value is less than 3. Is that an and statement? Yes, it is, because I'm looking for values between 3 and -3. Greater than, on the other hand, let's think what it means to be greater than. Does 4 work? Does 3? 2?
No.
1,
No.
0,
No.
negative 1,
No.
negative 2,
No.
negative 3,
No.
negative 4,
No.
negative 6.
Yes.
Does positive 6 work? You kind of in your head picture, we're trying to eliminate this whole middle section. We're trying to eliminate this whole middle section. With less than, I want to find this whole middle section. That's what makes it an and statement. I want all these numbers between. So less than tells me I want to find this. If I would change this to a greater than statement, instead of looking for what's in the middle, we would actually looking for this blue section. I'd be looking what's outside of it. And that's what we're looking for on the next thing. I'm not looking for what's between those two values. I'm looking for what's on the outside of it. And that's why I need to write two statements. Our first statement is x is greater than 5. So that should be the easy one. Just remove your absolute values. Our next one can get a little trickier, because you do have to have a negative 5. And because it's negative, we are going to flip the symbol. Now I'm setting
I
up.
thought that was only if you divide and multiply.
Because negative 6 is less than negative 5.
Highlighted it and told you make sure to be careful about this. You flip here because I'm making this negative. And in fact, we technically flip the symbol here without knowing it, because this is now x is greater than negative 3. So technically it's flipped. It's just how we write it that it doesn't look flipped. So this one is the one that people find easier because they think they're not flipping it, but you are. Here you actually explicitly have to flip it. You have to do this, guys. And you're going to realize when you graph it if you made a mistake. All right, let's go ahead and graph this. So we're looking for values of, let's go ahead and mark it 5. Oof, that's still my line tool. 5, 0, and negative 5. Once again, if it was a less than symbol, we'd be looking for this stuff. But it's greater than, so we're going to match those. I'm looking for where x is greater than 5, so that's going to look like that. No equal sign, so no brackets. X is less than negative 5, once again a parenthesis, because we're not including negative 5. And that's what an or statement looks like. If you make a mistake, if, like Erna, you forget on the test that you need to flip that, this is what's going to happen. If you forget to flip it, you're going to easily figure out your mistake, because you would now have this, and you'd say, well, that doesn't make any sense. It's busted. You're going to come up with a busted graph if you make mistakes on these. So you got to remember to flip it, which will come up with a graph that makes sense. Let's go ahead and write our solution in sets notation. And that's going to be negative infinity. Infinity always has a parenthesis on it. To negative 5, parenthesis, because we don't have any equal signs. We're going to union that with 5 to infinity. Boom, done. But it all goes back to just studying this, guys. What to do when it's less than, what to do when it's greater than. And barring the fact that maybe you forget it when you get to the test, just break it down to absolute value is greater than 3, absolute value is less than 3, and just see how it works. Break things down to simple problems for you if you get to the test and you forget. That's why we start with these basic ones, because you can always break it back down to that. All right, our next problem says 3x plus 2 absolute value is bigger than negative 7. Who wants to make this a really easy problem? Or who wants to go on the test and solve it and figure out? Dave, you want to make this easier?
Yeah, sure.
What's the answer to this?
No answer.
Ooh, opposite. Think opposite.
All solutions.
It is all solutions.
Because it's greater than a negative number.
It is greater than a negative number. When?
Everything is greater. Everything in absolute value is greater.
What's the smallest value an absolute value can be?
0.
0. Is 0 bigger than negative 7?
Yes.
And that's the smallest it can be.
So it's all positives.
It is all solutions of x.
Because if you put a negative in absolute value, it becomes a positive.
It becomes a positive.
It's just the distance from
It's just the distance from 0. Distance cannot be negative. So this is going to be all real solutions.
We have to add the real.
It can't be imaginary. I'd be okay with all solutions. I'm not gonna nitpick. I'm just happy that you would realize that on a test. All right, I'm really just trying to push this fact that absolute value is a distance. It is always positive or 0. So if I ask when is it bigger than -7, it's going to be always. A distance is always 0. Let's change this one just a little bit. Let's go hypothetical land. Hypothetical land. Is that still all solutions?
It's no solution.
It is no solutions because I'm asking when is it going to be -8, -9. It'll never be negative, so that would be no solutions. Just like if I put a equal to sign there, it would be no solutions. But greater than?
Wow.
All solutions. So remember, the smallest value in absolute value can be is 0, and then ask yourself, does it work? So negatives are always going to throw a wrench in absolute value. So anytime you see a negative on the right-hand side, stop and think. Don't just do work and get -2 points. Then when you get it back, you're like, oh, that was the no solution one. Because you all said it when you got it back. All right. But don't rush it. Because this one looks like it has a negative on the right-hand side, but it really doesn't.
No, because you divide.
I need to first get the absolute value alone, so I'm going to divide by a -2. And then I do have to flip the signs. So I have 4 minus x. So a lot of stuff happens in this problem. Probably a good problem, right? I don't know. If I'm looking for a test problem, this is a good one because I am asking you to take your time, divide by a -2, and flip. So that's a lot happening all in one step. Now it's possible, all right? It is not all or no solutions because I no longer have the negative because I first had to get the absolute. Now it's a greater than. Greater than is the ones that go in opposite directions, so it's going to be an or statement. It's going to be an or statement. So we're going to rewrite this as two statements. We're going to rewrite it as 4 minus x is greater than or equal to 2. Or we're going to have 4 minus x. Remember to flip your sign because I'm going to the negative land of -2. So don't forget to flip your sign because we're going to negative land. It's a wonderful place. All right, we're going to subtract 4 on both sides. So I have -x is bigger than or equal to -2. I am dividing or multiplying by -1. Both work.
Flip the sign.
But I do need to flip the sign. Thank you. Is 2. Or we're going to do the same thing over here. So we're going to have -x is less than or equal to -6. Once again, I'm multiplying or dividing by a negative, so I flip the sign. And let's go ahead and graph it. And we're at, I guess we'll do 2, 4, 6. I'm looking for where x is bigger than or equal to 6. So that means I need to use a bracket or a closed dot if you prefer. And it has to be less than or equal to 2, so bracket. And the good thing is this is how it should look. Nothing should overlap and look wonky. And let's just notation this. We're going to go from -infinity all the way to 2. We're going to union that with 6 to infinity. And I did everything perfect, so quit raising your hands and telling me it's all wrong. Quit it. Luke, what's wrong with that?
You need brackets.
I need brackets. Oh, that's important?
Yes, because it includes the 2
Oh.
and 6.
That shouldn't be the only reason. It makes it right. Who cares about the point? We want to get it right. There we go. So I have brackets. That's true. That's just me telling you did it wrong. All right, so we got brackets, and we move on. All right, these next two are kind of application problems. Yay.
Yay!
They're super easy if you just practice them. The ones I put on the test would be identical to these. There's no real thought process to it once you see them done once. So the first one says a student received a 74 on a midterm exam. To get a B, the average of her midterm and her final need to be between an 80 and 89 inclusive. I'm going to highlight a word there, and that is inclusive. Inclusive tells you you need to use less than or equal to or greater than or equal to. Just make sure there's an equal to sign in it. Inclusive means include those values. What range of possible scores on the final would give the student a B in the course? So let's first talk about average. How do I get the average of two tests? Well, the average would be one test plus the final, which we haven't taken yet, so let's make that x, divided by 2. That would be my average score of the two tests. I want that average to be somewhere between 80 and 89 inclusive. So the lowest score I want on it would be an 80. The highest score I want on it is an 89. Well, I'd like higher, but to get a B, I want to do that. Well, that means that average has to be somewhere between these two. So let's throw that average right between them. 74 plus x divided by 2. Boom. That is saying my average score is going to be somewhere between 80 and 89 if that x fits the situation. Now we just have to solve for x to figure out what score that needs to be. Because remember, 74 is the midterm. X is our final. Maybe I should write that somewhere. I don't really have room. So this is my midterm. This x is my final. I almost put final. Final. All right, so we solve for x. First, we multiply all three sides by 2 to get me 160 is less than or equal to 74 plus x is less than or equal to 180, 178. Now I subtract 74 from all three sides, which would be 86 on this side. Less than or equal to x is less than or equal to 104, which means to score on this test, I have to get somewhere between an 86 and a 104 with brackets, because it is included. Inclusive means brackets. Is it that bad of a word problem?
No.
It will look the exact same if I put this on the test. I will say the hardest one, there's one on the ones where we have a weighted one, and you'll have to think through that one. But these shouldn't be that hard. Even the next one, it looks hard, but if you study for just a second and just pay attention to what I'm saying. So you have a different definition of relative error, a little more exact. It says if L is the actual length, weight, degree. Oh, sorry, Chris, yeah.
Would you want us to include above 100 because it's like?
Is it realistic? Probably not realistic, but could there be extra credit on it?
Technically, yes.
Technically, yes. So on my notes, I did put a realistic one would be 86 to 100, but this is what I accept for. If you went...
Did you take both?
Yeah, absolutely.
Okay.
Yeah. I understand there's a realistic aspect and a mathematical aspect that you could get a 104, but usually can't on a final. Yeah, a more realistic answer would be 86 to 100, but I'll accept either one of those answers is 100% correct.
Okay. Thank you.
Yep. Okay, so you have kind of relative error. That's the only one we're caring about is relative error. Don't worry about absolute error. So we'll just eliminate that. And you just have to memorize this formula. And this formula, the big thing you have to remember is this L is that actual weight, length, temperature, whatever they're giving you. All right, and this x, when we solve for this x, is going to actually be what succeeds in this equation, and you'll know what I mean once I solve this one. It'll make more sense. So just remember relative error and that equation. So it says a technician is testing a scale with a 50-pound block of steel. So that 50-pound block of steel is an actual weight. That will actually be your L value. That is the fixed weight, that fixed temperature, whatever they're giving, whatever the fixed thing is, that is going to be your L. The scale passes this test if the relative error when weighing the block is less than 0.1%. So picture this. I am weighing this 50-pound block, and as long as it's just a little bit over or a little bit under, my scale passes. If it's too far over or too far under, we throw it away. I don't know what we do with it. It just doesn't pass the test. And that test, it has to be within 0.1%. So let's rewrite 0.1% as a decimal. 0.1% is actually equal to 0.001. All right. If x is the reading on the scale, then for what value x does the scale pass the test? So we don't know the value of x, so that helps us while filling this out. And we're just going to go x minus our L value divided by our L value must be, and let's highlight this, it says less than, so we're not going to use an equal sign, but it has to be less than that 0.1%, which we said was 0.001. Now when we solve this, we're going to come up with two weights, the lower end of the weight and the upper end of the weight being wrong on the scale, I guess. So the first thing I'll do is multiply both sides by 50 to give me x minus 50 is less than 0.050. We really don't need that 0 in the end. I'll probably get rid in the next step, but for right now we'll leave it. Now it's an absolute value that's less than. Absolute values that are less than are between two things. Just like our absolute value was less than 3, it was between 3 and negative 3. This is one that's between. And so a less than we're going to rewrite as one equation. That will be negative 0.05 is less than x minus 50 is less than 0.05. Now we just add 50 to both sides, yeah?
Oh, wait, no, never mind.
Okay, now we just add 50 to both sides to get me 49.95. Has to be less, or x has to be bigger than that, which has to be less than 50.05. So as long as the scale is between 49.95 and 50.05, it passes. Are there other ways to solve this problem? Absolutely. I don't care what method you did, as long as your method is valid, all right? Because you can just find what's 0.1% of 50, add and subtract it. It's the same thing we're doing here. This is just setting it up. Yeah?
So if this said it was inclusive, then would it be brackets and not
Yes,
parentheses? Okay.
correct. And this would say weighing this block is less than or equal to 0.1%, or that's probably the best way in that one. Yeah, if this is something about inclusive, then yes. All right, any questions on that? All right, cool. We do have a test coming up Thursday. You do have your review. It'd probably be really smart to start working on your review tonight, so you don't have a blank thing. I will be checking at the end of class. I'm still leaning towards we will not do test corrections unless you fail it. So unless you fail it, and in which case you only can get an 80% is your maximum score. All right, so if you get below an 80%, you can possibly do test corrections. Maybe not. Haven't fully decided. Just because it's so hard after 2 weeks to come back and then trying to get those collected. Second of all, I have softball after school, so we no longer have after schools available to do it with me. So just make sure you get it done just in case you possibly have to do the test corrections. Because if you don't have it done and you fail, you're just in the boat of failing a test because you didn't do that work beforehand. Yeah?
When did we get the review?
Yesterday. So if you weren't here yesterday, it'll be in that bin up there. All right, any questions for me? All right, let's go ahead and get started working.